Swayam Prabha. Digital India. Educated India.
Namaskar, my name is Umesh Rathod. I'm from the Ministry of Education's Innovation Cell. Today with me, I have another team from the School Innovation Contest, the winners from Jammu Kashmir Anantnag region. I would like to welcome the team who has developed drip irrigation through atmospheric pressure. I have the mentor of the team and the mentees as well. So let's move on to the mentor and try to understand what they are doing. So, sir, can you introduce quickly about yourself?
Hello everyone, my name is Wasim Muzaffar and I am presently working as a teacher at Rathod Public School, Anantnag, and we are here with our prototype, that's drip irrigation by atmospheric moisture.
Moisture.
Exactly.
Right.
Well, I am Zainab Azad, representing Rathod Public School, Batingu, Anantnag, Jammu and Kashmir. I'm a 9th grader.
Okay.
Greetings everyone, it's me Hadia Jan from the same school and I am leading this team and we are here with our project converting atmospheric moisture and using that for the drip irrigation system.
Okay. So, how did this idea came to you?
Yes, so actually what we observe that is, even if it doesn't rain, moisture is still present in the atmosphere. And also in some areas of our country, like in the semi-arid and arid areas, there are still farmers that struggle with the problem of water scarcity. Okay. So what we are going to exactly do is, we aim to solve that very problem. So a system, it's going to trap that atmospheric moisture, and then as you can see here, the frost is being developed, and later on this frost will melt and it will change to water, and then we can use that very water for drinking purposes and also for the drip irrigation.
Okay. So, are there any existing solutions available like this, where we convert the atmospheric moisture into, we are able to use it for drinking or other purposes?
So basically there are not the solutions present. There are traditional methods like we're having well, tube wells, etc. But they are not, that effective. So that's why we came up with the idea, and this is using simple chemistry and the simple physics which we are using in the project. So there aren't present any solutions like this, but the traditional methods that we are having.
Okay. So what was the support provided to the young minds when they came up with this idea for the School Innovation Contest from the school and the School Innovation Council?
Actually, if we will talk about the one thing that I want to highlight here is, in our country, as if we will talk about, there is no dearth of innovative ideas or innovations or innovative ideas among the students. Two things as a teacher I can say here, that one thing is that's a guidance they needed, and second is the platform they needed. So as a guy, for guidance, we are teachers here to guide them, and for the platforms, I would like to thank for that, for AICTE, Ministry of Education and Innovation Cell, that for providing such platforms. And whenever they required any sort of help as a mentor, I was always there. And platforms are already provided by the Government of India from time to time, so that helped a lot for the students, to showcase their ideas or to showcase their innovation skills. So I'm highly thankful for that. I'm
glad to know that. So when you make such kind of a solution, I believe you require the technological support as well. Not just mentoring, but the tools are also required. So how did you go about assessing what tools you need and then building this kind of a solution?
So we were in the class 7th and we were reading about the interparticle force of attraction and interparticle space. So there we read that if we increase the interparticle force of attraction and decrease the interparticle space between the gaseous molecules, we can convert them into the liquid. So then we were like, we need to, solve the problem of the irrigation, and we had something in back of the mind. So we're like, where from we'll get these tools. So we talked to sir, sir was like, sir did a research, we did a research. So we got to know that the same thing is used in the refrigerator. Basically the compressor we have used, this is the same used in the refrigerators or the ACs you see. So there we got to know that it can generate the pressure by which we can collect. So that was where we got it to know.
Okay. So, what were the other challenges which you came across while building this?
If you talk about the different challenges are there, it's actually the hardware part challenge that about the coils, how many size of a coil we require for this prototype, about the compressor, about the different things. Even if I want to add one more thing here, that our project, it's a solar powered, it's not an electricity filter, it's a solar powered. So calculating the energy we needed in form of solar panels we need. So we have already solar panels with us, not here, but at school we have solar panels, battery it needs, inverter it needs. So doing that all sort of calculation, all sort of energy it requires for different things. So it requires it was a kind of difficult for us, but at last time we can say that we have came up with a solution that how it will work.
Okay, let's look at the demonstration. I would be happy if you can share how it works and what are the various parts of it.
Okay, fine. So first and foremost, we have the compressor as said by Hadia, and this is the same compressor that's used in the refrigerator. What does this compressor does actually? In the atmosphere, we have the moisture. So this helps in trapping the moisture. It's the basic concept of water cycle, that condensation. And same thing as you can see here, the frost is being developed over these copper insulated wires. And after a few minutes, you will also experience that this what we can say, this frost will melt in water. After that, we can use the same water that's being collected over here for the irrigation purposes and for the drinking purpose as well.
Okay, so you are repurposing the refrigeration compressor for the drip irrigation.
Yes, exactly, sir.
Okay, okay. What are the future scope, like when you want to launch it at scale, you want to commercialize it now? So what kind of handholding support you wish to have, or what is that in your mind, how you want to take it ahead?
I can say, first of all, we need a patent, to secure everything. We need financial support. Second thing, we need a copyright on the idea. And third thing, we need a team, because nothing we can do without a team. So we need a proper team for us to invest on this.
Okay. So I congratulate you for this.
Thank you, sir.
Great feat. You have won the school innovation contest. I hope many more such inventive ideas will come from your school and from your team as well.
Yes.
So wish you all the best for your future endeavors.
Thank you.
Thank you, sir.
Thank you
Thank you so much.
So that was the team from Anantnag, Jammu and Kashmir, who has built a wonderful product for converting the moisture in the air into water. One of the basic and the one of the sustainable development goals issue, where water is one of the crises we are facing globally. So how, using the basic concept of condensation, they have made this prototype and now want to scale it further. Innovations like this only affirm that the young Indians are able to solve the problem for Viksit Bharat and make sure that we succeed in all fronts. I congratulate the team, that is the mentor and the mentees of the project, for their successful endeavors and their entrepreneurial journey ahead.